Hello and good afternoon, CTS267 Section 840 students at Anne Arundel Community College. This is the CCNP TSHOOT course, and this afternoon's video tutorial is going to be our third and final look at the SECHNIK Networking Ltd. Troubleshooting scenarios here. So this is going to be challenge number 3, and let's go ahead and dive in. Again, the network topology is remaining the same, so we should at this point be extremely familiar with it. Let's come up to our scenario here. Again, challenge number 3. So the first ticket that we've got, so users on PC 1 and 2 are reporting that they do not have internet access, and so let's note this site down here that they're trying to get to, 209.165.201.225. So let's go ahead and dive in. Let's continue to follow our process that we've been establishing here, which is let's confirm first that we don't have connectivity. So let's try to ping to 209.165.201.225, and you can see it says unrecognized host or address. So let's see, show IP interface brief. Do we have an IP? So again, we should be familiar with this, right? So right out of the gate, we use ping for divide and conquer. We see that the issue is probably below layer 3. So PC2 is also having the same issue. So let's come over to PC2 and see what we can see over here. So let's say ping to 209.165.201.225. And do we have the same issue? Show IP interface brief. We do. And so the reason that I wouldn't trace route at this point is we don't have an IP. So even if I was to 225, even if I was to trace, you can see it's going to come back and say unrecognized host or address because we don't have an IP. And if we're supposed to get that IP via DHCP, remember, that's probably where we're going to be getting the default gateway and the other information that we're going to require to move around. So we look at the diagram. PC1 and PC2 both terminate here on ASW1. So let's come up to ASW1 and let's do a show interface status. And we see that we're connected on Ethernet 01 and 02. And that the VLANs look correct in terms of the VLAN assignment looks correct. So let's take a look at each of those individual interfaces. So show run interface Ethernet 01. And you can see everything looks good there, right? VLAN, and show run interface Ethernet 02. And so everything looks good there. Now, we're familiar with this network, so we know that this is a trunk link between ASW1 and DSW1. So let's come back and let's see from a trunk port perspective, show interface trunk, because we want to make sure that our VLAN is being allowed to go through there. And as you can see, the VLAN is allowed on the trunk, VLAN 10 as well as VLAN 20 across a trunk link. The trunk link is up and it's trunking, right? So if we were to say show run interface Ethernet 00, everything looks good there. So now let's go ahead and step up to the distribution layer switch. And let's see what we can see here. So let's start out with a show interface trunk. Make sure that the distribution layer switch is also allowing VLANs 10 and 20 through. It is. So everything looks good there. So from a layer 2 perspective, it appears that we're able to reach from the PC, that reachability from the PC from a layer 2 perspective is being facilitated. Now, if I was to say show, and actually if we were to come back down to ASW1 and say show MAC address table, so we can see from the MAC address table the MACs that we're learning dynamically for VLAN 10 as well as for VLAN 20. And so let's take a quick peek here at the job aids. So we're going to try to see if we have layer 2 reachability. So Ethernet 01 comes all the way up here to, this is on DSW1. So I want to see the MAC address. So show interface Ethernet 01. So here is the MAC address. So what we're going to do now, and we're going to go ahead and let's see, AABBCC, so 4710. So I'm going to come down to PC1 and, or actually not even PC1, to ASW1, and let's say traceroute MAC. And it's not going to let us do, and let me make sure I've got that syntax right. It should just be traceroute MAC. Let's double check this though. And let's make sure. So do they have that traceroute MAC? Yeah, so traceroute MAC is a good way to trace from a source MAC to a destination MAC. I was going to trace to see if we can make our way up there to the distribution layer switch, but the command does not appear to be available here on the access layer switch. So that's okay, because in the end we'll probably find out that it's not going to be our problem here. So we can get all the way to the distribution layer switch, right? And we're not getting IP addresses via DHCP, but everything from layer 2, and we know layer 1 is good, and everything through layer 2 looks good. So let's take a look at the show run section DHCP. And whoops, we don't see anything there, so it looks like we're going to have to go, maybe the DHCP addresses are coming off of router 1 here. So let's check that. Show run section DHCP. All right, so it looks like the address information is being given out by router 1 this time. So here's VLAN 10's pool. Everything looks good. The default router looks good. The DNS server looks good. And we've got our lease statement. All right, so this looks good, but when we're talking about DHCP, remember, we're going across layer 3 devices with this distro layer switch and the router. And so what that typically means is that in the VLAN, show run interface VLAN 10, is that we should have a helper address. Right, so here's IP helper address 172.16.100.1, and let's see what that looks like for VLAN 20. And we've got 172.16.200.1. So if we were to take a look again at the job aid, what we're going to see here, I believe, if 200 is still over, let's see, so VLAN 10 and VLAN 20, and do they have, yeah, so the server is 210, and I don't believe 201 is the IP address. It should be router 1's interface, 172.16.100.1. So I think this is correct here on VLAN 10, but it looks incorrect on VLAN 20. And so let's go ahead on DSW, the distribution layer switch. Let's get into interface VLAN 20, and let's put in the right helper address, because if I was to ping 172.16.200.1, you can see here we don't get a response back because I don't believe this IP is being used. And it would be on that 200 segment with the server, which isn't the helper address we want to provide. So we're going to say no IP helper address 172.16.200.1, whoops, 200.1, and we're going to come back with IP helper address 172.16.100.1. And so what's interesting here is it fixes, this is an issue with VLAN 20, but it doesn't address anything with VLAN 10. So if I come back over here to the PC, if I were to get into global config and say interface Ethernet 00, and let's shut this interface down and wait till we get confirmation that it's down, and then say no shut, and let's give it an opportunity here to fire out a DHCP discover packet. And do we see an address? Show IP interface brief. No, we still don't have an address. Let's check over here on PC2. Do we have an address? Let's say interface 00, and we're going to say shut, because the mistake we found was for VLAN 20, and we'll say no shut. And let's see, does this make things any better on VLAN 20? Is VLAN 20 going to get an IP address now? All right, so we found one fault, and it doesn't look like we pick up an IP, right? So again, we can kind of look at this and deduce that we've got it's a common problem that both PC1 and PC2, even though the configuration option for the helper address, the helper address was fixed here on DSW1, we're still not able to reach router 1 in order to pick up the IP, that it's not able to make it down to us. And so let's take a look here at DSW1, and let's say do show IP interface brief. And we see the VLAN 10 and the VLAN 20. We've got a loop back and that Ethernet 00. So let's see, let's make sure we've got connectivity here. Do ping 172.16.100.1. And we do, and that's router 1. So now let's take a look at the routing table here. And you can see that everything we've got everything is locally, everything's directly connected here. Let's take a look at router 1, show IP route. So router 1 has a static, and then everything else is directly connected. Now if I look back at my job aid, I could have swore that it shows us here, OSPF area 0, and we've got a default route that should be injected into OSPF here. Router ID is 111. So let's take a look at router 1. Let's say show run, let's say show run section OSPF. And this looks like it could be the problem here. So you can see we've got router OSPF 1, and we're redistributing connected. We've got default information originate, and that's fine, but we've got this passive interface default. So what about a show IP OSPF neighbors? Do I have any OSPF neighbors? No. Show IP OSPF interface brief, and we misspelled OSPF. So Ethernet 02, we should be running OSPF on, and that's the interface between the distribution layer switch. And so this right here would be and could be a common fault that's impacting router 1 from even communicating with those PCs, because if there's no routing information set up or being shared between router 1 and the distribution layer switch. In fact, if I were to come back to this distribution layer switch, you can see, let's see, show run and begin router OSPF. And so here we go, passive interface default, but we have no passive interface, Ethernet 00. And again, the two VLANs are also no passive interfaced. But again, you can clearly see here that we've taken into account the interfaces on which we want OSPF hello packets to be sent. So what we're going to do is we're going to say, back over here on router 1, we're going to go into global config, and we're going to say router OSPF 1, no passive interface, Ethernet 02. Now this should bring up, and pretty quickly, the OSPF neighbor adjacency. So now when I say show IP OSPF interface brief, we still see Ethernet 02, but when I say show IP OSPF neighbors, you can clearly see that now we have an OSPF adjacency. So if I say show run, or how about show IP route OSPF, now I'm learning the networks for the 192.168.10 and the 192.168.20, which we didn't see before. All we saw before were the directly connected networks. And so if we come down here, take a look, all right, everything looks great here. We've just picked up an IP address on PC1. We now have an IP address here on PC2. And so let's confirm that we can actually reach 209.165.201.225. And we should have connectivity. We do. How about a trace to 209.165.201.225 numeric? That way we're not trying to resolve the IPs to host names. And there we go, right? So connectivity looks good. Run the same check quickly here, and we're going to say ping 209.165.201.225. All right, so connectivity for PC1 and PC2 has been established. Again, we started at a sort of a divide and conquer. We ran the ping command, and then we realized that we had a passive interface that was involved, as well as having to resolve the helper address issue with DHCP. We kind of followed our layer 2 after divide and conquer, made it up to up to router 1 in the distribution layer switch for the helper address, and saw that there was some misconfiguration there. And again, layer 3 being misconfigured. So this was an instance where we ran ping, and it immediately wasn't apparent that the problem was not at layer 2, right? So we were good layer 2 all the way through. We had misconfiguration at layer 3. So that's definitely a use case where ping doesn't eliminate layer 3, right? That we had issues at layer 3 with our DHCP setup as well as with the passive interface. Okay, so now we're going to be taking a look at the final, I think there were only 2 here. Okay, your ISP, and now this one should be pretty straightforward because we've got quite a bit of information here. So your ISP has informed you that it's changing its first hop IP address from 2001 DB8, etc., ::2 to ::33. So this should scream router 1, that it's probably something on router 1. So, and it even, when I continue to read here, Peter has reconfigured router 1 and informed the ISP that it can change its address. But Carol, a user on PC3, quickly reported to Peter that she cannot get to the internet. So let's write this internet address down: 2001 DB8 :AA::B. All right, so with this, we can use sort of the shoot from the hip or the hunch, right? That Peter did something on router 1. He had probably changed the peering address here on router 1, that something was done and we've lost internet connectivity. So we jump onto router 1 here, and let's take a look at show run interface Ethernet 01. So there's my link to the internet. You can see there's the IPv6 address that I'm using, is that 2001 DB8 D1 A5 Charlie 8 ::1. So let's see, can I ping 2001 :DB8 :D1 :A5 Charlie 8 I'm sorry, it wasn't 2, they were changing it to 33. So I was pinging the old address there. Let me pull back the command and let's see if we can ping 33. So they definitely changed their side, right? And take a look at that. We can ping without any issues. Okay, so now Carol's on PC3. So again, we're pretty sure it was something here on router 1. Let's come to PC3 and let's see if we can ping 2001 DB8 :AA::B. So, and, you know, again, confirming that, hey, Carol said she can't ping, so this looks like it could be a problem. Can I trace do it? Let's try to trace to 2001 DB8 :AA, I'm sorry, yeah, :AA::B. And I should have done numeric, but we'll let this run its course. All right, so I get to 2008 DB1A ::1. I get to 11::1. And so 11::1, my guess is that is up on router 1. So let's do a quick show IPv6 interface brief. And sure enough, it's that Ethernet 02 interface. So we can, you know, again, everything is pointing to something on router 1. So we can get to router 1. At this point, let's see, show IPv6 route. Let's see what router 1 believes the next hop should be for that network. Let's see if we even have, so we've got a static, and let's see what else we've got here. There's the 11 with a RIP directly connected, and so it appears that that is the old address. So it appears that a static route is set up to go to the Charlie 8 ::2. However, let's confirm this. We tried to ping that and it didn't work. I want to make sure that that was the change that was being made, not the job aids. Sorry, we want the scenario. And let's see here. Yep. And they were changing. So it looks like Peter failed to change or remove or update the static route. So here we are. Let's say show run include route. I see what Peter did. So here's what Peter did. Peter added in the correct IPv6 static route. However, he added it in with an administrative distance of 2, which is greater than the default administrative distance for a static route, which is 1. Therefore, the correct IPv6 static route is not going to be entered into the RIB. It's going to be the static with the lower administrative distance. And let's double check that. Yeah, it only entered that single static. So what we need to do, and this is pretty straightforward, is to simply say no IPv6 route, :/0, and we're going to set this out to, we need to get rid of 2001 : DB8 : Delta 1 : Alpha 5 : Charlie 8 : 2 do show run include route. Now we can leave this in there. If we were to say do show IPv6 route now, you're going to see that it's in there with an administrative distance of 2. So this is not going to hurt anything as long as nobody enters in another static route with a lower administrative distance. Which is what we had happen when we were trying to get out to the, another default static route out of the enterprise. All right, so this, let's go back to Carol's PC and let's trace, and actually IPv6, we can't numeric it. So we're going to go ahead and come back here and let's see what happens now. We get to A1, which is our default gateway. We get to 11.1, which is router 1. And then we make it out to the internet service provider. So does Carol have reachability? She can trace route out there, DB8 : A : B, and we've got the ping is working great, right? So again, sort of walking through, taking the information that's been given to you and determining where you should start. And again, very helpful when we looked at that second scenario, right? We had quite a bit of information here. ISP's changing its first hop IP address. Peter says he reconfigured router 1, and then Carol says everything's broke. So from that, we can deduce that Peter must have done something on router 1 that wasn't correct. All right, so this is going to wrap up the SECHNIK Networking Ltd. Trouble ticket scenarios. Hopefully this has cleared things up, and again, follow that process. Stick to the process that we're using, right? Choose one of the troubleshooting approaches, and then go from there. All right, guys, thanks for watching, and I will see you Thursday night.